Okay, let's start to the architecture of 8086. Okay, from this diagram, this is the also we can say that this is the internal building block of 8086. We can say that it has two parts. Actually, this is the execution unit. Okay, execution unit doing all the operations. And what is the role of bus interface unit? Bus interface unit helps the execution unit to brings the data from memory interface unit to the execution unit. It has some bus interface unit. It brings the data to here. After the data comes through here, it has arithmetic logical unit, some operation. With the help of that, it doing some operations. So I can explain easily that just imagine a school. That I can say that one school like DAV or any English medium or any developed school, I can say that it is an execution unit. Okay, and every schools, they have some buses, so they are providing some buses. And who are the data? Data are the students, and this memory it is their house, students' house. And in the morning time, what is the role of bus? The role of bus to pick up the students from their houses or from their bus stands, and its role is to drop the students at school. Once it reached at the school, that means execution unit, the role of the school or execution unit to teaching or some other purposes. After the school closed at evening time or afternoon time, again the role of execution unit or bus interface unit to pick up the students from the school and drop them at their respective places, at their respective locations. Now I am going to discuss each part of execution unit. After that I will jump to bus interface unit. So what are the parts of okay, to what better understand, I suggest you to print this diagram in your mind. So here, what are the parts of execution unit? Part is arithmetic logical unit, ALU. It is one part I will discuss. Then another second part is here control unit. We will discuss what is the role of control unit. Then third part is this is the registers. These registers are known as general purpose registers, and these are known as index registers. I will discuss index registers. And another register available, that flags. So flag registers. So you remember three important parts. One is no need to concentrate on operands, no need to think about that. Part one is arithmetic logical unit. Second is your control unit. Third is your registers. Register divided three parts. One is general purpose register, index register, flags. Okay, next go to let's go to discuss about this every parts. Okay, so okay, now start. This is the part. Okay, now start about this. In the I already told you 8086 divided two parts, execution unit and bus interface unit. This is the execution unit. Okay, so I already described what is the main two important function of execution unit. One function of execution unit to instruct the bus interface unit for data or instruction management, means where to bring the data, and or after the operation where to store the data. That means it instruct the bus interface unit. That means who will instruct? The execution unit will instruct. The second part is control, and it also execution unit also control on data through instruction decoder and ALU. Through ALU and instruction decoder, it controls on the data. So next is okay, so we will jump one after one. What are the parts of functional unit? Start with ALU. Okay, then control register, then general purpose register, then go for flag register. Okay, so now I am going to start with let's start with ALU. You know ALU stands for, I think it is one of the easy thing, every computer science students know what is ALU. ALU, arithmetic logical unit. Arithmetic logical unit, it performs all the arithmetic operations like addition, subtraction, multiplication, division, and logical operations like OR and NOT. All the operations it performs. Then second part is control unit. Control unit, actually what is the role? At each clock pulse, actually computer has a clock, it generates clock pulses. At each clock pulse, control unit actually it receives the instruction, and in every instruction there is a opcode available and an operand available. Opcode, in opcode it decodes, it has instruction decoder, it decodes, and after decodes it generates signals, it generates control signal. Through that, let your control addition operation, that add operand available, that means it instruct ALU to perform addition operation, so that according to the code it generates different signal. It may be to control the ALU, or it may be control the registers, or it may be control your buses. So these operations it performs. Then jump to EU, that is AU registers. What are the AU registers? Basically three types of registers available. One is general purpose register, then index register, then flag register. So let's start with general purpose registers. So what is general purpose registers? It do some normal operations, normal works. So there are four types of general purpose registers. One is your and all the general purpose registers, they are 16 bits in size, and they are also divided into two parts. Here what are the general purpose registers? AX, BX, CX, DX, and I can divide AX into two parts. One is AH and AL. AH is in higher 8 bit, and this is the lower 8 bit. This is the lower 8 bit, and this is the higher 8 bit. Okay, so exactly in the same way, BX also, B upper part BH, lower part BL, CH CL, DX DL. Likewise all the things are we can divide. DH DL, CH CL, all are 8 bit. BH BL, and BH is the basically this is the higher, and this is the lower part. Okay, lower 8 bit parts. So then what is the role of AX? AX also known as accumulator. Actually, while we are performing arithmetic addition subtraction operation, one operand value should be stored in your accumulator, and then perform the different types of operations, and finally after the operation again the value will send to any different parts of the memory. So this is the accumulator. Okay, so then second part is base register. What is base register? Base register actually stores the starting base address of your memory area of data segment. I will discuss what are the segments available in bus interface units. So basically in your data divided in different parts, different segments, it indicates the starting address of the data segment. I will discuss. Then third is your counter. The counter, what is the role of counter? We are performing loop type of instruction. What is the role it counter is working? For example, I want to run a instruction 10 times, 100 times. So here counter value 110 like this, and that much times the instruction will, or block of instruction will execute again and again. Once the condition becomes false, it in the execution will stop. That is loop. I think all of you know that. Last part is your this is your DX actually it performs some IO port address, or some means it performs some operation with the port, or for example, let I want to print, means IO operations like so before I print the value, my result should be stored in DX. After that, DX content can print on the screen. Again at the same time, if I want to give some input value to my computer, first the data will go to DX. After DX hold, from DX the data can go to different parts. So for that purposes the DX registers is used. Okay, so let's jump next part is your okay, this thing finished. So this next is your one register, general register finished. Then go for index registers. So what is index registers? The main work of index registers actually contains the offset for segment register. What is offset? What is your segment register? Segment registers available in bus interface unit. What is offset? Actually, segment register 16 bit, and your index register, these are also 16 bit. All are 16 bits. So but I already told you 8086 is a 20 bit, 8086 20 bit. So 20 bit address, how can we present 20 bit physical address in the with the help of, so that means these are 16, your index register 16 bit, segment register 16 bit. So these are whole logical address. Segment register hold the logical base address, and these are offset address, and with the help of base address and the offset address we calculate the physical address. I will discuss next in the bus interface unit. So for now you have to remember that index registers holds the offset address. Along with the offset address, it has some different, it also supports some different functions, like let's start with the BP. What is base pointer? BP stands for base pointer, and it work is okay, it work is actually it is offset of it is the offset of a stack segment. Segment 4 types I will discuss. Remember, stack segment, it holds stack base address, and a base pointer is the holds the offset of stack segment to determine the location of a variable in the stack. For that purpose, base pointer is used. And what is stack pointer? Stack pointer actually it is also holds the offset for stack segment, and it with the help of this stack segment and SP we determine the location of stack top. For that purpose we are using. The next part is SI. What is SI? SI is the source index. Source index is actually source is the offset for data segment. Okay, SI is the offset for data segment, and also it is used for while you are copying string. It is work as the source. It is basically while you are copying from one data from one file to another file. At that time, one variable to another variable, the string will store in this location. For this is the source index, and exactly that while you are copying from source to destination, and this register is work as the destination. And DI also used for the segment offset for your extra segment. There are actually 4 segment available. One is data segment, one is a core segment, one is your extra segment, and another is stack segment. All the segment I will discuss in next. Okay, the flag registers are 16-bit in size. Basically, they shows the status of your result. They store the status of the result stored in the accumulator. See, this is 16-bit in size from 0 to this is from 0 to 15. This is 16-bit in size. Okay, so this is known as carry flag. Carry flag basically shows after the operation finished, addition or any operation finished, if that generates any carry, then this bit set to 1. If no carry generates, this bit set to 0. This is the carry flag. The next comes, this is the parity flag. Parity flag basically it checks the lower 8 bit of the result. If the lower 8 bit contains even number of 1, that is even parity, and this result set to this bit set to 1. If this contains odd number of 1, this parity bit set to 0. Next come to auxiliary flag. What is auxiliary flag? Every number in 8086, for example, if I consider a number 48, its binary equivalent, let us consider 1000 and 40100. If I want to do any addition operation with this number to this number and this randomly 0, let it like this. If I am going to do some addition operation, let this is after addition 0, this is 0, this is 1 plus 1 10, so 0 here 1 comes to here. That means here 1 this generates, this means 1 generates, 1 carry generates, and this 1 added to this result, this becomes 1 1 1 0. This is the result. So here in this operation 1 carry generates, this carry generates, this parts is known as this lower 4 bits. Every 4 bits is known as nibbles. This is lower nibble, this is the upper nibble. If any carry generates from the lower nibble to the upper nibble, then this bit set to 1, otherwise this bit 0. Then go to 0 flag, ZF. 0 flag means if your final result contain 0, if it is 0, the result is 0, then this bit is set to 1, otherwise 0. This is sign flag, SF. Sign flag means if your result negative, it is 1, otherwise 0. And come to the last flag, OF, overflow flag. Overflow, when your result crosses the range of numbers defined by your 8086 processor, then this bit set to 1. And all the 5 flags in this register, 1 2 3 4 5, this 5 flag is known as conditional flags, because this depends on the condition of the result stored in the accumulator. If the result changes every time, this value changes. That means these flags depends on the result of the result stored in the accumulator. These are the conditional. This shows the status of the result stored in the accumulator. These are the conditional flag. It depends on the condition of the result stored in the accumulator. Then jump to some flags left. This is TF, known as trap flag. Trap flag means it instruct the processor to run one instruction at a time. Basically, it is used in debugging operations. Next is interrupt flag. What is interrupt flag? Interrupt flag means basically while your processor is doing some operations, if this interrupt bit set to 1, let it is set to 1, then your processor halt, and if any it holds some time. If a new operation come, it do that operation, and after finish that operation, then the processor can do its own work. If that bit set to 0, then the processor no need to wait, it will do its own work. That means every time while processor going to work, it check the interrupt flag. If interrupt flag is 1, then it do the new operation what is coming. The interrupt operation what interrupt define, that operation the processor will do. If not, if it is 0, no need to worry about anything, the processor will do its own work. So if for example, if a teacher in a class doing some work, let's say he is doing some work, and new student will come for signature of his copy. So what the teacher will do, if that is very important copy or important information, so the teacher will stop his work for some time and do the signature or any other work, and after that work finished, the student left that place, then the teacher again do his own work. This is just like interrupt. Okay, then another is the directional flag, DF. This directional flag DF, basically it is used while we are performing string operations. It, from its name, it defines the direction, in huge direction the string access the memory, from higher memory or higher order memory to lower order memory, or from lower order memory to higher order memory. Accordingly, its value set. So this DF, and IF and TF, these three are known as your control registers, because they control the execution of your processor. These are control flags. And the remaining 6, 1, 2, 3, 4, 5 and 6, these remaining 6 are known as conditional flags. These are known as the conditional flags. These remaining 6 are known as conditional flags. Okay, they define the condition, this and this. So there are total, out of 16 bit, there are 9 bits are used, and remaining are undefined. Okay, these are the registers. So jump to, so whatever I discussed, it is available, you can see here. Flag register divided two groups: conditional flag, control flags. I have already told everything what is conditional flag. You see carry flag here. Next is what is carry flag, auxiliary flag, parity, zero, sign, overflow, everything I discussed. Then next part is you can your control flag. What are the control flag? I already told. Trap, you can see here what is trap flag. Okay, this is the trap. Next is your interrupt flag, then next is directional. Everything I discussed. So your control flag finished. To understand bus interface unit betterly, let's go to the architecture part. So this is the architectural part. In the architecture part, you see this is the execution unit, and this is your bus interface unit. This is the memory unit. Okay, I already told you execution unit do all the operations. It also perform all the operation execution, and all the operations are performed by the execution unit. While execution unit want to access any memory location, while it want to do any work, it instruct the bus interface unit to access the data from memory or from port address, and the bus interface unit receives this data and supplies this data to the execution unit through its internal buses. So this is the job of bus interface unit. And at the same time, if your execution unit finished any operation, so the data execution unit want to store in memory location. So what it will do, it instruct the bus interface unit to receive the data and store the data in respective memory location. So this is the work of bus interface unit. That means it reads the data from memory, and after finish the operation it also writes the data in the corresponding memory location. That work is done by bus interface unit. So let's jump to start with what are the parts or what are the functional units of bus interface unit. This is one, that is instruction queue. It is one instruction Q1. Then another part is these 4 registers ES, CS, SS, DS. They are segment registers: data segment, stack segment, code segment, extra segment. And another is, this is the instruction pointer. This is instruction pointer IP. So first, this second, this is third part, and last part there is adder. We will discuss every part one by one. Okay, then start with instruction queue. Instruction queue, this is 6 byte in size. So what is the role of a instruction queue? Actually, instruction queue is not available in 8085. It is one of the extra features of 8086, advanced features of 8086. Just think that let's just consider that there is, imagine there is no instruction queue. So if no instruction queue, so how the system will work? Let your execution unit want to want to do any work. So to do or to access any instruction or to access any data, what it will do, it instruct the bus interface unit to bring the data from memory. After bus interface unit brings the data from memory interface unit, after it brings and supply to execution unit. Once execution unit gets the data, it will start its work. Then what will happen? Let's after finish that work, for the next instruction, if execution unit want to work, say again it will tell the bus interface unit go there and brings the data, so that I will do this work. So what will happen? This is just like series. It tells the bus interface unit bring one data, bring one instruction. It will do that work. After finish that work, again say the bus interface unit bring next instruction. Then after finish that instruction, then say the bus interface unit brings another next instruction. So what is that? This is just like series. It takes one, do that, again instruct bus interface unit, fetches the next instruction, it will do that, then again fetches the next instruction. It is just like series and it will take more time. So to eliminate that problem, there is instruction queue available. So what it will work? So how it will work? Basically, it holds the next 6 byte of instruction for the execution unit. For example, execution unit while want to do its work, let's say execution unit is ready. So it will not depends on bus interface unit, because bus interface unit already fetched the instruction and keep it here. So execution unit takes the data from instruction queue and start its work, and while finish its work, while it wants next instruction, that next instruction already stored here from every time. That means what execution unit want to work, the next instruction already fetched by the bus interface unit and keep in instruction queue. So it just work as a middle, just like middle storage. No need to go to main store. In the middle store, while we want to work, execution unit want to work, it takes the data from here and performs work. It takes the data from here to perform this work. So like this. So execution bus interface unit, the role of bus interface unit, it fetches the next instruction execution unit want to run, it fetches from the memory and store here, and so bus interface unit takes the data from here and performs the works. So it supports pipelining concept, because while execution unit doing work on one instruction, let here running one instruction, at the same time what next instruction execution unit want, at the same time bus interface unit do the work of fetching. That means while it performing execution, while execution unit performing execution on a current instruction, at the same time bus interface unit fetches the next instruction and saves at or store at your instruction queue. That means two operations at the same time. It perform fetch instruction and this fetches the your execution operation. So two instruction, two work running at the same time. Due to two work running at the same time, the processor works faster than 8085. okay, so this is the work of instruction queue. okay, then next go to the segment register. There are 4 segment registers available. Segment registers actually used to hold the base address of segment of memory. I will tell next. So just for imagine, just remember, these are the segment register. They hold the base address of segment of the memory. In the memory there are segment available. Data segment holds the chunk of memory in the data. It holds the base address of data segment of the memory, and exactly a stack segment, it holds the base address of the stack segment available in the memory. I will discuss in next. Code segment, it holds the base address of the code segment that is available in memory. That means inside the memory there is available. While you are writing program, there are some available chunks of memory. This is like code segment, this is data segment, like this available. It only holds their base address. This is 16 bit. Remember, these segment registers are 16 bit in size, and it cannot keep whole data here. Let here in the memory, this is code segment is size is 64 KB. okay, 64 KB. It cannot, your code segment cannot hold 64 KB, but it can hold the base address. Let here the base address size is 16 bit. That base address size you can keep by the code segment. Actually, I will discuss how the addressing scheme. I will discuss in the adder. What is the role of adder? I will discuss for this purpose. For this now, just remember, these are the code segment register. These are the segment registers. The segment register hold the base address of the corresponding segments in the memory. Next is IP. What is instruction pointer? Instruction pointer holds the 16-bit address of the next instruction. Next instruction means what next instruction your execution unit is going to run. That instruction, that address of the next instruction is held by the IP. okay, next is adder.